Today we're going to be talking about section 6.5, which is on graphing square root and cube root functions. Our goal today is to graph those two types of functions. One, the square roots, and the second one would be the cube roots. So we talk about a radical function. That's a function that contains a radical with a variable in its radicand. So what we're going to be doing is looking at functions that have square roots today and functions that are cube roots. So we're going to talk about the parent function for a square root and the cube root function. The first one we're going to look at is the square root. And the parent function of the family of square root functions is f of x equals the square root of x. So we're going to plug in our ordered pairs. If I put in 0, I'm going to get 0. If I put in 1, I'm going to get 1 because the square root of 1 is 1. If I put in 4, I'm going to get 2. And so my graph is going to look like this. Now notice I only put in numbers that were really easy for me to figure out. I didn't put in 2 because the square root of 2 is a decimal, but I know. So when I use a square root function, I'm going to put in 0, 1, and 4. Notice I also didn't put any negative numbers because the negative square root of a negative number is imaginary. So this is my parent function for the square root function. So let's do the same thing for the cube root. Here I put in 0, I get 0. If I put in 1, the third root of 1 is 1. Now the next number I'm going to put in is 8. So if we put in 8, we're going to get 2. So if I put in 8, we get 2. Now, in a third root or a cube root function, we can also put in the negative number. So if we put in -1, the third root of -1 is -1, and the third root of -8 is -2. So in this case, our parent function is going to look like that. So we have the parent function of both our square root, which is the one on the left, and our cube root, which is the one on the right. So in example 1, what we're going to be doing is looking at how to graph these. So we're going to graph y equals -2 times the square root of x and state the domain and the range. And then we're going to compare it with the parent function of y equals square root of x. So I'm going to take my parent function, and this one's a square root, so I'm going to just draw that on here real quick. So I'm going to compare it with that. So in this case, I'm going to do the same thing. I'm just going to plug points into that equation. So again, 0. I put in 0. The square root of 0 is 0. So 0 times -2 is 0. Put in 1, we get 1. So the 1 times -2 is -2. We put in 4. Square root of 4 is 2. 2 times -2 is -4. So our function is going to look like this. So when we talk about the domain and the range of this, now remember, our domain is our x values. And if we look at the graph, it's going to go to the right forever. It will not go to the left forever. The smallest value of x that we're going to have is 0. So my domain is going to be x is greater than or equal to 0. Now if we look at the y values, which is the range, it will go down forever, but it will not go up. So the graph here is y is going to be less than or equal to 0. So that's our domain and our range. And now if we compare these two, we know that it's obviously a reflection, and we talked about these before. So it's a reflection and a vertical stretch. And there's our graph. So now we're going to do the same thing in example 2 with a cube root. Again, I'm just going to start by quickly throwing up our parent function. So if we do that 0, 0, 1, 1, 8, 2, -1, -1, -8, 2. Okay, so there's what our parent function looks like. Now I'm going to do that part of it. And again, I'm going to use 0, 1, and 8, and -1 and -8 as my points because they all have third roots. It's going to make our math pretty easy. So if I put in 0, I'm going to get 0. If I put in 1, that third root of 1 is 1. So then we're going to get 1.5. If I put in 8, that's 2. So I'm going to get 3. And the same thing down here, I'll get negative 1.5 and negative 3. So now our graph looks like this. So when we come into the domain, it goes forever to the right, it goes forever to the left, so our domain is all real numbers. Our y values, it goes up forever, it goes down forever. Again, so this one is all real numbers. And then if we compare these two, the only thing it did in this case was stretch, so it is a vertical stretch. Okay, and remember before we talked about reflections, we talked about vertical stretches, we talked about vertical shrinks. So we talked about a variety of those different types of things. The next thing we're going to talk about, example 3 says, it's a multi-step problem. It says biologists have found that the shoulder height h in centimeters of a male African elephant can be modeled by this equation, h equals 62.5 times the third root of t plus 75.8, where t is the elephant's age in years. So we're going to use a graphing calculator to model this function. So what I want you to do is pull up your graphing calculator, and we're going to type this in. So we're going to go to this, and we're going to type in that function. So go ahead and type in the function. So 62.5, and I'm going to go to the third root. All right, let's try that again. We're going to have 62.5, and then we're going to have the third root of t, so x, and then we make sure we get out of that square, or the third root, and then we have our 75.8. We hit enter, and then we're going to graph it. All right, so we're going to look at what this graph looks like. And notice here, did I type that in? Let's come back to our graph here. Oh, I forgot to put my plus 75.8. So I got to insert that. There, now let's graph it. Now, it's not going to show up on this chart because my intercept is 75.8. So it means it goes up 75.8. And we're only really looking for quadrant 1 here because that's a real life situation. So we need that. So what we're going to do is we're going to zoom out. And we're going to go until we can find where this comes into quadrant 1. So if we watch this graph come up, all right, still, so we need to zoom out again. So now, but I'm going to zoom out up here. Oh, so let's go zoom. I'm going to zoom out, and I'm going to come up here a ways, wherever I can get to. So I'm going to zoom out up to the top of the graph. I want to find where it comes into quadrant 1. All right, so here comes our graph. And now what we want to do is we want to look at estimate where the elephant has a shoulder height of 200 centimeters. Now, if we're looking at 200 centimeters, that's what h is. So we want to find out, and essentially in this equation, that's when y is. So we want to find out when y is 200 centimeters. So what we're going to do is we're going to trace this, and we're going to find out when y is 200 centimeters. Okay, so right here, that's about where it's at, but I want to get a better idea. So now let's zoom back in now that we found their graph. And so we're going to zoom into that part of the graph so we can be more accurate with our data. And so we're going to find out, we're going to try to get this as close to 200 as possible. Still not very close, so let's zoom in here again. We're zoomed out quite a ways in that. So what you can do is you could go to the windows and you could zoom or change your Windows settings as well rather than do the zooms. But if we go to the trace, so now I'm getting more numbers that are right there, is about 200 for my Y value. And so this is about 7.9 years. So in about 7.9 years, the elephant's going to be 200 centimeters tall. Okay, so that's how we would answer this question. Estimate the elephant's shoulder height, and it would be the elephant is going to be about 7.9 years old. Now, likewise, we could do the same type of question here. If we want to know how tall is the elephant going to be when it's 15 years old, all we have to do is find out when this elephant is 15, and you can either trace that, or if you're looking for that one, in some calculators you can just hit the 15 and go over to where the Y value is, and it'll say, oh, it's about 230 centimeters tall when it's 15 years old. Okay. So we can use our graph to find out pieces of data like that. So let's go back to our problems here. Let's do questions. We don't have to do all of those. Let's do one on square roots and one on cube roots. So the one in the, let's do question 2 and question 4. So go ahead and do questions 2 and questions 4. You can pause the video, and when you're ready, you can hit play. And here are the answers to those 2 guided practice questions. We graphed in the blue is the parent function, just f of x equals square root of x in the first one, and f of x equals the third root of x in the second one. And then we graph those. The first one is going to be a vertical shrink because that number 1/4 is a fraction. It's smaller than 1. Remember, we talked about those before. And so the domain is x is greater than or equal to 0, and y is greater than or equal to 0 because it's everything to the right and everything above 0. In number 4, it's a vertical stretch because that number is bigger than 1. 4 is bigger than 1. And the domain and the range is both all real numbers. So again, a quick review of the graphs of radical functions. Remember, this HK, H means it's going to be a shift to the right or left, and K means up or down. So that's what we're going to look at in both of these cases. So what we want to do is sketch the graph exactly like we did, and then we're just going to shift it left or right or up or down depending on what those values in the inside are. And we've talked about those vertical shifts and horizontal shifts before. So let's do these equations. So the first one, again, I'm going to take it, I'm going to graph that. So if I put in my numbers, 0, I'm going to get 0. 1, I'm going to get square root of 1 is 1 times 3 is 3, so it's 1, 3. And then square root of 4 is 2, so that's going to be 2 times 3 is 6. So here is the part that I have squared in blue. Well, now, if we look at this, we know that this is shifted 2 units to the left and down 4. So I'm going to take these 3 points here that we put in, and we're going to go left 2, down 4. So I'm going to go left 2, down 1, 2, 3, 4. Left 1, 2, down 1, 2, 3, 4. left 2, down 1, 2, 3, 4. And so my graph is going to look like that. So the black graph is the graph of that equation. So that is the whole thing. And if we look at the domain, now the domain, the smallest value of x is going to be -2, so x is going to be greater than or equal to -2. The smallest value for y is -4, so its y is going to be greater than or equal to -4. So there's our domain in a range. The black function is the graph of that square root function. The same thing is true for our cube root functions in example 5. Again, we're going to start with this part of it. We're just going to take the cube root of it. And again, I'm going to put in, because it's a third root, I'm going to put in 0, 1, 8, -1, -8, because I know the third root of all of those. So if I put in 0, I'm going to get 0. Obviously, anything times 0 is 0. Put in 1. So that's -2.5. Well, if I put in -1, it's going to be +2.5. All right, well, let's put in 8. That's 2. The third root of 8 is 2. And so that's going to give us -5. And then if I put in -8, I'm going to get +5. So that is the part of that I have squared, or it's a rectangle, but circled in blue. So if we take and do the whole thing, now this is a shift of 2 units to the right and up 3. Okay, remember, it's always going to be the opposite of whatever that sign is in there. So it's right 2, up 3. So let's take our points and we're going to go right 2. So 1, 2, up 1, 2, 3. And that was this point in the 0, 0. So that was this point here. 2.5 is right here. Let me make these bigger so we can see which ones we're doing. All right, so the next I'm going to take the point 1, -2.5, and again, right 2, up 3. 1, 2, up 1, 2, 3, that's right here. 1, 2, 1, 2, 3, that's right here. Same thing. We're going to go right 2, up 1, 2, 3, right 2, up 1, 2, 3. And so here is our graph of that function. And again, we see it goes right forever, goes left forever, goes up forever, goes down forever. So both the domain and the range in this one are all real numbers. So unless there's a restriction on the third root, the domain and the range will always be all real numbers. So what we're going to do now is we're going to look at a couple of guided practice questions. And there are 6 of them in your notes. We're just going to do one of the square root ones. So let's start with that. Let's look at doing question number 7. All right, so go ahead and do number 7. When you are finished with that one, you can pause the video, or you can pause the video now. When you're done with that one, you can hit play and see what those gave us. If we look at this example, again, the blue one is what I did with that part that's underlined, and then it's just a horizontal shift, left 1 unit. So I moved everything left 1 unit, and so my domain is x is greater than or equal to -1, and y is greater than or equal to 0. So let's go to the third root functions. So let's look at example. We'll do one of these as well, and we'll do one that has a horizontal and a vertical shift for this one. Actually, let's do number 10. We'll do number 10. This one should have only a horizontal shift. If you look at number 9, number 9 has a horizontal shift. Number 10 has only a vertical shift, and number 11 has both a horizontal and a vertical shift. So let's look at number 10 and do that one, and we'll see that this one has only a vertical shift. So go ahead and pause the video, and you can hit play when you are ready. All right, so if we look at the graph of number 10, again, this one we're just shifting it down 5 units. So that's going to tell us that we're going to graph the blue part with the dotted line, the part that I have underlined, and then it's just going to be shifted down 5 units. And again, this has a domain and a range of all real numbers. So as a recap, today essentially we graph square root functions, we graphed cube root functions. And we want to look at what happens with certain different numbers in here. So if we take a function like number 9, this number out front, that's going to tell if it is a vertical stretch or a vertical shrink. If that number is bigger than 1, then it's a vertical stretch. If it is a fraction, then it's a vertical shrink. Okay. Also, if that number would be negative, that's what's going to make it a reflection. The number inside the radical, whether it's here or here, is going to tell us which way it shifts, left or right. It's a horizontal shift. Okay, so the number inside the radical tells us that it's a horizontal shift, and the number outside of the radical, in this case, those are the vertical shifts. That tells us if it moves up or down. If it's negative, obviously, it's going to move down. If it's positive, it's going to move up. So that's what we're talking about in section 6.5 when we talk about square roots and cube roots. And here are the assignment sets for section 6.5. They are on page 449.